Hi everyone. In this video, I am going over the event problems for exam number 11 review. Okay, so you should all have the notes for this, and I'm going to go fast on this, so if you need to pause the video, go ahead and pause the video. And then you can also ask me questions in class. In class, you'll be doing the odd problems. Okay, so let's go ahead and get started. So for number 2, I'm going to decompose 80 as 8 times 10, and 8 is 4 times 2, and 4 is 2 times 2, and then 10 is 2 times 5. So then we have, let's see, a pair of 2's and another pair of 2's. Okay, so then you multiply 2 times 2, and that gives you a 4. And then we have x to the second, which means we can take out x, but then this 5 stays inside of the radical. Okay, so then this is x square root of 5. Now the index is even, meaning it's square root. The power of x is odd, therefore x needs to have absolute value around it. So that's number 2. Number 4, this is the cube root. So I'm going to decompose this as, let's see, 4 times, I can divide this by 4. I can also do 2 times 64. So 2 times 64, and 64, I'm going to do 27 times 2. And 27, as you saw in class, is 3 times 3 times 3. So we have 2 2's and 3 3's, which means we can take out a 3 and then multiply 2 times 2. So then we have a 3 coming out, cube root of 2 times 2, which is 4. Okay, again, I've explained this in class, so if you don't remember, you can ask me questions about this in class. All right, number 6 next. So this one is add and subtract. Now, at first, these will not look like terms, so I'm going to see if this simplifies so I can have a 6 inside of the radical. So 54, we can do, we can do it different ways. I'm going to do 2 times 27, and 27 is 3 times 3 times 3. So then I have 3 3's. I'm going to take out a 3. And there's a 3 waiting outside, so then this becomes 3 times 3, and then this 2 and that 3, we only have 1 of each, so to leave that 6 inside. So then this becomes, okay, this part here is 9 square root of 6, and then we have 2 of them here, so 2 plus 9 is 11, so then this is 11 square root of 6, and that's the answer to number 6. Number 8. Again, this is, let's see, the cube root, so we can take out x. So this becomes x cube root of 3. And this one, 24, is the same as, let's see, I'm going to see if I can, I think I'm going to have to give myself more space here. Hold on, I'm going to pause the video here. All right, so I just gave myself more space here. So notice 24 is the same as 3 times 8, but 8 is 2 times 2 times 2, so we have 3 2's. So then we have a negative 3 times a 2 coming out for this one, and then inside of the radical, which is the cube root, we have, let's see, that 3 left. Okay, that's this one here. The other one, we have 4 3's, so that means we can leave a 3 inside, but we also have x in here, right? This is x to the third. We can take 3 and x, so this is, let's see, plus 2 times 3 times x cube root of, we have this 3 left inside. So then this becomes negative 6x, so this is negative 6x cube root of 3, and this is positive 6x cube root of 3. And again, these are negative 6 of them. There's negative 6 of them here and positive 6 of them here, so those cancel. So then the answer to this is x times the cube root of 3. Okay, that's the answer to number 8. Number 10. We're multiplying radicals now. So this has an implied 1 in front of it. So 1 times 3 is 3. And then this is 5 times 5, which is 25. So you're multiplying those 5's. Minus 1 times 4 is 4. And 5 times 3, that's 15 inside of the radical. So we know that this is square root of 25 is 5, so this is 3 times 5 minus 4 square root of 15. 3 times 5 is 15. minus, we can't simplify anything here because 15 is 3 times 5, so we just leave it as 15. So 15 minus 4, square root of 15, and that's the answer to number 10. Number 12, we have the square for number 12. So the square means we have two of them, right? So then square root of 3 times square root of 3, that's square root of 9, plus square root of 3 times 4 square root of 7, that's 4 square root of 3 times 7 is 21. Okay, so that's 3 times 7. Plus square root of 7, 4 square root of 7 times square root of 3, that's plus 4 square root of 21. And then 4 square root of 7 times 4 square root of 7, that's plus 16 square root of 49. But again, we know this is 3. We know this is 16 times 7, because square root of 49 is 7. And this is 4 plus 4, so this is plus 8 square root of 21. And again, 21, you can try to decompose this, and the only factors are 3 and 1. You only have 3 and 7, you only have one of each. You can't take anything out. 16 times 7 gives you 112. So then when you add 3 and 112, that's 115 plus 8 square root of 21. So that's the answer to number 12. Number 14. So for number 14, we have a radical in the denominator, so we need to rationalize. Okay, so we can't take anything out of the radical. This is the cube root, and we need to get the 3x out of it. So that means we need, we have 1 3, we need 2 more 3's and 2 more x's. So then multiply by the cube root of 3 times x over the cube root of, again, 3 times x. So then that gives you, let's see, so the numerator, let's see what happens here. So we have, in the denominator, we have 3x, right? Because we have 3 3's, we can take out the 3, and we have 3 x's, we can take out the x. And then in the numerator, we have 3 times 3, which is 9 times 5. So that's the cube root of 45, and then this is x times x, which is x squared. So then the answer to this is cube root of 45 x squared over 3x, and that cannot simplify it any further. Okay, all right, number 16. So for this one, I'm going to multiply, this is the square root, so I'm going to multiply by the square root of 7, because I have a 7 inside of the radical. I just need one more to be able to get rid of that, or rationalize the denominator. So then this is 8 times 7, which is 56, right? So this is the square root of 56 over 2 times 7. And then let's see if this simplifies. So I'm going to do the square root of 56 here, and I'm going to do 2 times 28, and then 28 is the same as 4 times 7, and 4 is the same as 2 times 2, right? So we have 3 2's. We can take a 2 out, and then we have a 7 here. So then 2 comes out. This is that 2, and then multiply 2 times 7. So inside of the radical, we have a 14 left over 2 times 7, which is 14, but this reduces even further because it goes into 14 twice. So I'm going to erase that 14 and make it a 7, and then erase that 2. So this is what we have left. Okay, the square root of 14 over 7. That's the simplest form for this problem. All right, let's go to the next page. This page is complex conjugates. So then we know the complex conjugate of 3 minus 2i is 3 plus 2i. Okay, so multiply numerator and denominator again, because we can't have I in the denominator. So then I'm going to expand this. 2 times 3 is 6. 2 times 4i, 2 times 2i is 4i. And then I times 3 is 3i. And I times 2i is plus 2i squared over 3 times 3, that's 9. 3 times 2i is plus 6i. Negative 2 times 3i, that's negative 6i. And negative 2i times 2i is negative 4i squared. But then remember that I squared is equal to negative 1. So this becomes 2 times negative 1. So this 2 becomes a negative 2. and this negative 4, you're multiplying it by a negative 1, which becomes a positive 4, right? So then we have 6 minus 2. That's a, so let's see, that's a 4. And then 4i plus 3i, that's 7i. And denominator is 9 plus 4, which is 13. So this is the answer to this one, 4 plus 7i over 13. Okay? All right, number 18, solve by using substitution. So this will be a fun one to do. So what I am going to do is I'm going to go to this equation, the first equation, and substitute for y in here, because y is equal to negative 2x plus 3. So then I'm going to say negative 2x plus 3 equals x squared minus 6x plus 3. Then I'm going to jump these two terms to the other side, meaning I'm going to add 2x and I'm going to subtract 3, right? So then this becomes a 0. 0 equals x squared. Negative 6x plus 2x is negative 4x. And 3 minus 3 is 0. So then those cancel. So then there's a GCF of x here. So x times x minus 4. And then that means x equals 0 and x minus 4 equals 0. Which means for this one, x equals 4. So I need to find the y coordinates now. So I'm going to go to the second equation and find the y value. So y equals negative 2. I'm going to use 0 first. Negative 2 times 0 plus 3, which means y equals 3. So then one point of intersection is where x is 0, y is positive 3. And the other point is y equals negative 2 instead of x, 4 plus 3. So that means negative 2 times 4 is negative 8 plus 3. Negative 8 plus 3 is negative 5. So when x is 4, y is negative 5. So these two graphs, this line and this parabola, will intersect at these coordinates. Okay. All right. So last even problem is number 20. This is a quadratic. Notice has a negative value for a. A is negative 1. So the graph opens down. So it goes to the left 2, up 4. So left 1, 2, up 1, 2, 3, 4. Then left 1, down 1, left 1, 2, down 1, 2, 3, 4. Right 1, down 1, right 2, down 4. And then when I sketch the graph, it looks like this. And again, this is review. So this is coming from the previous semester and also the beginning of this spring semester of 2026. Okay. Well, thank you for watching. I'll see you in the classroom. Bye-bye.